Done? Now listen. Now what do you think we need to do for second minimum? So for second minimum, how many parts are we supposed to break the slit into?
4.
That's it. So the same slit, you will break it into 4 different parts. 4 equal parts, okay? Such that one ray will go from here, one ray will go from here, third from here, and fourth from here. S1, S2, S3, and S4. This is theta 4, theta 4, theta 4, and theta 4. Point P double dash. Now you people tell me what should happen. Since we are saying minimum, it should be a dark spot. For dark spot to appear, what should have happened? The rays from S1 P dash, the rays from S1 and S2 at point P double dash should undergo what kind of interference?
Destructive.
Destructive. Now, the one from S3, okay, if it is odd number, what will happen is when 2 rays are there, the 2 rays need to always undergo destructive interference. Then the third ray will go and add some brightness to it. Then what will the fourth ray do? So S1 and S2, the rays from S1 and S2 will undergo destructive. So you have a dark spot here. Similarly, the rays from S3 and S4 will undergo destructive. Still, you have a dark spot there. Okay. So what will be the distance between S1 and S2? It will be d by 4. This I need not explain. So path difference between S1 P double dash and S2 P double dash should be equal to lambda by 2 because they are subsequent rays, right? So d by 4 times sine theta 4 should be equal to how much? Lambda by 4. Sorry, lambda by 2. So d sine theta 4 will be equal to 2 lambda. What is this? This is the condition for second minimum. Now you guys tell me, for me to explain, so what I've done is I've done alternate things. Now let's come in the order. So for explaining central maximum, you kept it as 1 slit. For explaining first minimum, we broke it into 2 slits. First secondary maximum, 3 slits. Second minimum, 4 slits. Now for second secondary maximum, how many slits are we supposed to take?
5 slits.
It will be 5. Okay. So even without doing, what do you think will be the condition for second secondary maximum? If you observe, for all the derivations, the right hand side is the same, lambda by 2, because we are taking subsequent rays. Okay. Sine theta is also common. D is also common. What is happening to the denominator?
D by 5.
It will be the number of slits. It will be d by 5, which implies d sine theta is equal to 5 times lambda by 2. Similarly, what will be the condition for third minimum? What will be the condition for third minimum?
Lambda.
Yes, 3 lambda. Fourth minimum, 8 lambda, 4 lambda. Okay, keep on going like this. So, if I conclude everything, now observe, condition for central maximum, path difference is 0. Condition for first secondary maximum, d sine theta is equal to 3 lambda by 2. Condition for second secondary maximum, d sine theta is equal to 5 lambda by 2. Right. So you people told me that condition for third secondary maximum, d sine theta will be equal to 7 lambda by 2. In a similar way, what will be the condition for nth secondary maximum, guys? D sine theta should be equal to
2n plus 1
2n plus
lambda
1
by 2.
lambda by 2.
2n plus 1 into lambda by 2. Don't write minus 1. Because if you observe everywhere, it is 2n plus 1 only. So if you put 2 here, 4 plus 1, 5 lambda by 2. So for second, 5 lambda by 2. If you put 3 here, it will be 7 lambda by 2. That is the condition for third. Got it? In a similar way, what will be the condition for first minimum? D sine theta will be equal to lambda. Condition for second minimum, D sine theta will be equal to 2 lambda. In a similar way, what will be the condition for nth minimum?
N lambda.
That's it. That's it, guys. Okay. Is it clear? Now see, in this, there are certain formula for diffraction, okay, not distraction. For diffraction at a single slit of width d, condition for nth minimum is n lambda, d sine theta is n lambda. Condition for nth secondary maximum is d sine theta is equal to 2n plus 1 into lambda by 2. And angular position of nth minimum. So angular position means what? So theta is small, d into theta will be equal to n into lambda, which implies theta is equal to n lambda divided by d. This is the angular position of what? Nth minimum. In a similar way, you people tell me what will be the angular position of nth secondary maximum. D theta will be equal to 2n plus 1 into lambda by 2, which implies theta will be equal to 2n plus 1 into lambda divided by 2. So this is the angle it is making with the horizontal. Similarly, this is the angle it is making with the horizontal. Am I clear, guys?
Yes, sir.
Yes, sir.
Okay. So distance of the nth secondary maximum from the center of the screen, this you can find it out. So how you will find this? See. If this is point O, okay, let's call this as the nth secondary maximum. Then it will make an angle theta. That's what I told, angular position of nth secondary maximum. What will be the value of theta? It will be 2n plus 1 into lambda divided by 2d. Correct? And
Yes, sir.
the distance from slit to O is capital D. Right? So this is the distance y. Can I call it as yn? Now, can I say yn divided by d is equal to tan theta? Yn divided by d is tan theta. When tan theta is small, it can be approximated to theta. So yn divided by capital D is equal to, what is the value of theta, guys? 2n plus 1 into lambda by 2d. So yn will be equal to 2n plus 1 into lambda into capital D divided by 2d. Did you guys understand what I did?
Yes, sir.
Similarly, can you find out what is the distance of nth minimum from central spot? When I say from central spot, from the center of the central spot. So yn divided by capital D will be how much? Same tan theta, but this time what is theta, guys?
N lambda.
That's right. So yn will be equal to n lambda into capital T divided by what am I
It's n
missing?
lambda by t. N lambda by d.
So n lambda into capital T divided by small d. Okay, that's it. So you have understood the concept. So those things are given here. Similarly, one important point to be noted here is the width of the central maxima is always double the width of any other maximum. Okay, please write it down. Width of the central maxima is 2 lambda into capital D by D. Okay. Let's find out why it is so. Width of central maxima. So what is the width of central maxima is? So if this is the width of central maxima, if I call it as beta, okay. So can I say central maxima is lying between two successive, or central maxima is lying between two bright spots that where one is taken on the top and the second is taken at the bottom. And which number does this bright spot take? Dark spot take? It is the first minimum. Correct? So if this is O, if I take this as theta, then guys tell me what will this value of y be? That is the distance from the center to the first minima. How much is this? First minimum is lambda into capital D by D. Accepted, guys? Because here you will substitute n is equal to 1. So lambda into capital D divided by D. Similarly, what will this y be? Y below is also equal to lambda into capital D by D. So fringe width of central maximum is how much? 2 times lambda into capital D by D, if we call this as beta. Did you guys understand what I did? So width of the central maxima is nothing but the distance between 2 times the distance between the central spot and the first minima. Right? Now, what is the width of any other maximum? So it is nothing but distance between nth minimum and n minus 1th minimum. Because see, if I take this as the spot, if this is the nth minimum, this will be n minus 1th minimum. In between, what will you have? You will have a bright spot, right? So yn minus yn minus 1 is nothing but n times lambda into capital D by D minus n minus 1 into lambda into capital D by D. What will you get? You will get lambda into capital D divided by small d. So what is the relation between the first and second equation? Guys, what is the distance between, so what is the relation between first and second?
Width of central maximum is 2 times the width of any other maximum.
Can I say width of any maximum is half of width of central maximum, or the vice versa? Width of the central maximum is 2 times the width of any other maximum. This might be a 1 mark question that they can ask. Okay. So I've covered all the points related to diffraction. There is nothing that is left. I've covered everything till here. Okay. So this part is not there. You need not worry about it. So what we will do is in the next class, we'll do some problems based on this topic. And I'll clear your doubts from interference also. With this major portion of physics is over. The remaining chapters are very, very easy. I can complete each chapter will maximum take 2 classes. Okay. So you have to
Sir,
start
can you
studying.
scroll it down, sir?
Yeah.
Yes,
Okay.
sir. Thank
So
you,
you have to
sir.
start preparing, guys. So I'll share this document now itself. Okay. Just wait, don't leave.